Well, welcome today. We're going to be talking about microservices, monoliths, and everything in between. So before we get started, we have our beautiful disclaimer here. If you want to take a picture of it and read it later, please feel free to do so. If you're a speed reader, you're already done. With that being said, and I see no cameras up, let's get started. Well, Cora, tell them about yourself.
Thank you. I'm Cora Iverclyde. I'm a developer advocate at Broadcom in the Tanzu division. I've worked with all kinds of technologies that are relevant to cloud, so I'm really happy to be here talking about these particular topics.
Well, folks, my name is Glenn. I'm one of the developers at Broadcom. I work on Spring projects. I work on Spring Integration, Spring Batch, and Spring Cloud Task. When I'm not doing that, I'm the board of directors of Atlanta Java Users Group, which means I'm also one of the folks that bring DevNexus, the largest Java conference in the US. I'm also a Java champion. And, I think we want to talk something a little bit about where we're going. Today, what we do is we're going to just cover the vocabulary. We want to make sure everybody's on the same sheet of paper. The other thing that we want to be able to do is then talk about how we can take a monolith and migrate it to a modulith. Once we do that, we're going to say, is there a case where I may take something out of a modulith and create microservices from those modules? With that being said, let's go through our vocabulary. So the first thing that we want to be able to do is look at what is a monolith. A monolith is kind of the traditional architecture that we use since the beginning of software engineering. Typically what it means is a single unified application that is both packaged, deployed, and scaled together. Now you say, what could advantages be with a monolith? Man, it's easy to start, right? But over time, what happens is some of that our various components get tightly coupled together, and then over time, it gets harder and harder to maintain. But then, about 10, 15 years ago, we said, what if we could do this? What if we would extract out the domains? Each domain gets a service. We get so many advantages through these microservices like independent deployment and scaling, polyglot tech and team autonomy, more resilient and modular. But as we saw some hands kind of shake up earlier, it gets more complex. Not only on the operations side, but also on the coding side. So we're going to introduce something today called a modulith. Basically, it is a monolith designed with well-encapsulated modules. We're going to talk a little bit more how we do that communicate through clear APIs and can evolve towards any boundaries. The cool part is we get those clear internal boundaries. Disadvantage is it still follows the same problem with monolith, that if one fails, it might bring down the whole app. But it's easier to test, deploy, and evolve. So this slide is what I call the it depends slide, right? This is a slide that you go in and you say, which one should I use? And here is a great slide that we can cover. Cora, can you tell us a little bit more about this?
Yes, I can. Yeah, so this slide, it kind of shows you, different factors on the left that might impact your decisions about which architecture to choose. And you can see that it also kind of reflects what were the problems with monoliths that we struggled with that it prompted us to switch to microservices over the, between 2010 and onwards, right, as microservices became very popular. So there was this promise of team agility. If everybody's working on their own repository, we won't be stepping on each other's code. There was the 12-factor apps that kind of guided us in how to manage individual applications in different repositories. Glenn mentioned the process level fault tolerance. You can scale things independently. So all of the things that were red X's in the monolith basically were solved by microservices. Except for ease of refactoring. Refactoring is really difficult with microservices because at the end of the day, when you realize that you've drawn your boundaries incorrectly, you have to actually move code from one Git repository to another. So it's not as trivial as just moving code, within your same project in your IDE from one package to another. So refactoring is not always trivial. And if you don't do your boundaries right, you still end up with sort of a big ball of mud, even though it's across network lines as opposed to direct calls inside of a monolith. So there's no guarantee, right, that just because it's a microservice, you've solved some of these problems. And I can take it actually.
Yeah, there you go.
Thank you. And so when we look at them, but some of the things that were positives for monoliths become challenges for microservices. So suddenly we're managing, a monolith is still, you can still scale a monolith and have some of the requirements of managing a distributed system because you have more than one process running. It's still connecting to things around it. But it's not as complex as a microservice architecture because you have less distribution to manage. That's why the bottom lines are on the monolith and modular monolith, the last one is not necessarily a green check mark, but it's not worse like in microservices. So the nice thing here is that you can see that a modular monolith, so applying those principles of a microservice of encapsulation with discipline inside of a monolith can kind of give us the best of both worlds. And then the two things that the process level fault tolerance and even the selective scalability are really not that big of a deal because you can still scale your monolith. You scale the whole thing. And I would say that recently with all of the improvements in Java 21, 25, with AOT and all this, efficiencies, the whole application can use so much less memory and start up faster that scaling the whole monolith is not as big of a deal as it might have been before. So with that, let's focus a little bit on some of the modernization strategies. So regardless of the architecture that you're choosing, whether it's a modular monolith or microservices, you still want to do your functional decomposition, right? So we're talking here about domain-driven design. And when we moved from monoliths to microservices, even the idea of domain-driven design precedes microservices, but domain-driven design got a lot of adoption and people became more aware of it and people got better at it because doing it with microservices just helped people with the concept and the diligence of doing this design. So you should be doing this regardless. So even if you're going to do your modular monolith, you still want to know what your domain boundaries are that make sense to your business because you're still going to draw the same lines, whether it's microservices or a monolith. So that's first. And then you can choose your architecture. So one of the things that we saw, which a lot of people here reflected that they've had this experience, is that we've over the last 10, 15 years, we've taken a lot of monoliths and converted them into microservices and done that functional decomposition and then separated everything into individual applications. So what we're proposing is that a better strategy is to take your legacy monolith or a new application and instead start by using this modular monolith approach. And then you can actually stop there. And then if you really have a legitimate reason to extract a module and start it up as a separate application, as a true microservice, then go ahead and do that. But the reasons for doing that are now much more sort of strategic and specific than just everything is a microservice, right? You might have, you still have your monolith, that's a well-defined modulith, and one or two microservices outside when you need them, right? So realistically, enterprises have all kinds of architecture for applications that have existed for a long time. So most likely you're going to have a mix of them. And even within one, big A application, you might have modulists talking to microservices, maybe even connecting still to an old monolith. So you're still going to have to manage all of these different kinds of architecture, right? Because not everything's greenfield. So from that perspective, what we want to show you is that the Spring ecosystem, regardless of what you're choosing or what you're managing, the Spring ecosystem has projects that will help you with the needs that you're going to have in both cases. So there is a specific project called Spring Monolith that will help you build a monolith following these modular ideas and keep the discipline and confidence that you're doing it correctly. And then for all of your distribution needs, you can still lean on Spring Cloud to fill those needs in. So I'll hand it over. We're going to be using an example to kind of drive these points through.
So all puns aside, we're creating a new business called RestBucks. And RestBucks actually takes in, basically allows people to order coffee. But one of the things we're offering through RestBucks is ability to have another service that allows executives to see how we're doing on that day. And we call that statistics, or basically our dashboard. Now, what we are going to do is we're going to take a monolith and change it into a modulith. So the first thing we need to do is we look on the left-hand side, and this is, in some cases, apps were built using, instead of, for their modularization, what they chose to use is the technology. So we see they kind of did a model view control technology stack for their modularization of their apps. But then they said, but the thing is that kind of leads to tight coupling, right? If I make a change to order, I have to make changes in all of those modules. But what if I said this? I would go in and identify my domains like I were going to deploy to a microservice, but I keep them within my modulith. So what we'll see is that I will have a dashboard, payment, order, and drinks. Now, that's great, but that doesn't protect me from what? That tight coupling. How can Spring Monolith help us do that? Now, the first thing is that through Spring Monolith, you can design what your modules are. Oh, by the way, if you're in the back, we have a bunch of seats up front, so come on up. I promise that I won't stare at you. Okay. In this case, what we'll say is that Spring Monolith allows you to go in and design your architecture. But you're like, well, I don't know where to start. So we're going to use the defaults of what Spring Monolith offers. So in this case, anytime you have a Spring Monolith, the first thing it's going to do, if you're using defaults, it's going to say, where's your app? And in that case, wherever your app is located, your app class, that's going to be called basically your base package. Each package that is in that base package will become a module according to Spring Monolith by default. So in this case, in our base package, we have core, dashboard, drinks, engine, and order. Those are my modules. Now, what are the rules it's going to enforce? The first rule is that any class that is in my module, like in the module order, remember, it used to be package, now it's a module. We have line item, location, order, and on. Any other module can access those classes, no problem. But what if I want to have code that I don't want other modules to touch? In that case, I will create a package within my module, in this case, web. And that says any class that's in that package will not be accessible by the other modules. For example, dashboard can touch line item, location, order, any of the other classes there. But if it tries to access something inside the web, it's going to get tagged as invalid. And you're like, okay, Glenn, that's great. When do we do this validation? Right now, we do it at the test time. So you basically are going to have a test, which is called verify modularity. That's what we call it. But what you're going to run is application modules dot of the name of the application, in this case, application.class, dot verify. And what happens is, if we go back to our original case where we actually broke a rule, we tried to access location drinks, which is in the web package, what happens is the following. Module dashboard depends on a non-exposed type in location and drinks, in order of location and drinks within the module order. So what are we saying? Is now at testing time, I can go in and say, okay, are all my rules correct? Or is my architecture correct based on the rules that we specified, in this case, the default? Now, the thing to remember about that is like, what value does that have? Well, one, as a developer, if I make a mistake, it's going to tag me, but it's really good for those new developers we're bringing on that we want them to follow the architectural decisions we have. Or when it's time for me to hand that application to a different team, they now know the architectural rules. And we can catch it at testing time. In the next release of Spring Monolith, which is going to be 2.0, you can do it at testing time. You can also enforce it at startup time, where it will actually enforce the rules before it even starts the app. It's up to you which one you want to use as of the Monolith 2.0. So you're like, Glenn, that's cool, but how do we get there from here? So we have that model persistence in web. So in Spring Monolith, what I can do is I can say, okay, right now, Spring Monolith, I'm going to install you, but for now, I want you to ignore model persistence in web. How can I do that? I will place an application module type open that says, look, please ignore this module for now. Don't scan it. Don't look at it. And so what will happen is I apply that to my package info.java, and I can put that in each of those modules, and it'll ignore them. Or I can create a package legacy or a module legacy, move them underneath that, those packages underneath the module legacy, and then what we'll see is, again, put a package info, and I say the type is open. What does that mean? It means over time, as we have resources, budget, and time, we can begin to extract out our domains. And as we extract out our domains, we then use, again, the defaults that come with Spring Monolith and be able to, extract out our domains. Eventually, replacing the original modules that were based on technology with domain. So before we go on, I want to just say, when you think about this migration, what we did in Monolith is an in-place replacement, right? We did it within the same app. While in the microservices, what we did was we typically do is a strangular pattern, where as we move the service off, we take and redirect the traffic from the primary legacy system to each of the services as we migrate them off. So what are some of the other things that we could do with Monolith? Cora, I'm curious now.
Well, now that you've got your application in a position where you can more easily migrate it, so as Glenn was saying, when you do, for example, that test verification to see if you've followed all of the rules, which by the way are a Spring opinionated implementation of ArcUnit for Java, architectural rules written in ArcUnit. So what Spring Monolith does is it looks at your application and it builds an in-memory representation of your architecture, of the domains that you have, of the modules that you have, the relationships, the access, and different top-level beans and things like that. So now that it knows what your architecture looks like, what's architecturally important, right? It can provide you additional capabilities. So here we've broken them down into design, integration, operations, and evolution. So I'm just going to cover a couple of these. So we've already talked about defining the structural arrangement, right? That's the default approach that every top-level package is a module, verifying those boundaries as Glenn described. And also Glenn already talked about the coexistence with legacy code so that you can do these ongoing architectural refinements. We can also talk a little bit about, okay, that yellow block should just look at the bold right now. Test modules independently and optimizing test execution. So these are two things that Spring Monolith enhances for testing. So one is that because it understands where your modules are, it can tell if you've just changed the code for one module rather than others, right? So when you run your tests again, it can optimize and only run your tests for the code, for the module, for the code that you changed. So your local testing is a little bit faster. And also, when you write your tests, with regular Spring Boot applications, you can choose to, for example, only load the web layer or only load the data layer, right? Things like that. But you're slicing the application horizontally in order to focus your tests, right? And save a little time. So in this case, it allows you to slice the application vertically. So in this case, if I only want to test the order module, but not the drinks module, I can do that. Or I can tell it, I want to test the order module, but please load the dependencies necessary so that these tests can execute, and it will do that automatically as well. Also, because it has an understanding of your application, you can automatically generate architectural documentation. And you also would do this through just a method as one of your tests. So just create documentation. And here you can see the kind of documents. So it generates a pummel diagram on the left showing you all of the relationships between things. Listens to means it's messaging. Depends on means it has access to code at the top level. And also a metadata table that also gives you what's architecturally important, right? It's not describing to you the implementation inside of your subdirectories inside of your module. It's just telling you what's architecturally important about your design. Okay, so then about integration. So that listens to relationship that we saw. So when you need one module to leverage another, so you can use the code or the objects that are at that top level of the classes for a module, but a more decoupled way to do it is to use events between modules. And so when you within one monolith, you can leverage Spring Framework's application events. So you can do message-based interactions between modules without external infrastructure like Rabbit or Kafka, right? It's all still within the same process. But application events in Spring, by default, have a configuration that would introduce some inefficiencies. And so what Spring Monolith does is it gives you an annotation called Application Module Listener that will automatically configure the interaction of two modules using application events so that the first module that's publishing the event can publish the event, close the commit boundary, and move on to other stuff. And the event that's subscribing will pick up that event and start its own commit boundary separately. Now, if we do that, of course, if the application crashes while the subscriber module is processing the event, we would lose that event, right? Because the publishing module has already closed the boundary and moved on. So for that, Spring Monolith provides an optional, the optional ability for the application to automatically publish the events into a database table. And so if the application crashes in between, when it starts up again, the subscriber can retrieve that event that hadn't been processed yet and reprocess it. So that's what we're showing in this slide. Okay, so then model distributed tracing. Again, sorry, that yellow block should be highlighting the top as well. So, so if you're working with microservices, you've already encountered the challenge of understanding the path of a single request as it does network hops, right, across different microservices to represent the life of one request. And so, I don't know if you're using the distributed tracing and maybe looking at those traces on something like Zipkin, but going to a monolith. So now you've got all these different functional logical modules inside of one process. You might still want to retain that ability to understand how a specific transaction goes through the different logical components. And so Spring Monolith will automatically, instead of just using distributed tracing, adding spans between network hops, it does it between interactions between modules. So you get that as well. And then you can look at it in Zipkin. And the nice thing here is that anything that is in the design stage or in the evolution stage is non-invasive to your code. So if you're just interested in getting that assistance, then you don't add anything to your actual production code. Of course, if you want the integration or you want the distributed tracing, then it adds a little bit of stuff in your code. So, all right, that's what Monolith gives you.
Okay, cool. Now, one of the things I wanted to cover really quick before we talk about microservice extraction is why would I want to stage and do monolith to monolith before going to microservice? One of the things that you want to be able to think about is like when I do this, now what I have created is these independent modules, right? That the only way that another module can access is it through its agreed to API. We're going to talk about how, like what Cora says, and now you can do this in venting. You can send messages between one another. So what this means is that now you can identify the problems that you'll have as you extract out these modules based on your domain. You do it within the application, and it's a lot simpler to be able to debug those. By doing that, then you can decide, well, maybe the monolith itself is okay. It's doing great, right? But there may be that one module in there that is happy. He's been migrated. They're in there and they're like snuggled up next to the other modules with this clear API. But maybe it needs to be pulled out and made into its own microservice. Why would we want to do that? It could be because it has a different scaling regime where maybe it's extremely popular. Like we're going to be talking about dashboard. Maybe it's getting hit so much that we're having to scale out our monolith just for that one service. So we may want to extract that out. We may have compliance issues where it cannot exist where it is currently at, and it needs to be moved somewhere else. And then we have many other reasons why we might want to extract a module out into a microservice. So this is where Spring Monolith also helps us again. As Cora showed us, it generates the documentation for us, right? So with that documentation, we see that we want to extract out dashboard. But we see that dashboard has a dependency on core. So when it's time for me to create my new service, I'm going to have to pull out core and dashboard, but also look, we have a listens to. It's listening to order. Anytime a new order is made, or it's called order paid, an event occurs, we now need to be able to get and create a wiretap and send that message, not only internally within the monolith, but externally as well to a messaging framework. So, what are our steps? So, step one is we need to externalize the messaging publication. So not only we want that message of the order paid to be going within the monolith, we want it to go to a messaging framework like a Kafka or a Rabbit. So how do we do that? So anytime we do that, one of the things I'm going to do is I need to go in and pull in either a Kafka starter dependency or an AMQ starter dependency if I'm using Rabbit. And then the next thing I need to do is add this little annotation here. And I'm going to add it to the order paid record. So anytime order paid is actually sent, right, internally within the monolith, it's going to wiretap it and send that same message out to the order paid exchange if we're using Rabbit, or the order paid topic if we're using Kafka. So now what we have is the ability to get that message here to the order paid, whatever messaging framework we use. The other thing that we want to be able to do, second step, is we need to start thinking about, okay, how am I going to route these messages instead of sending them, not yet, but instead of sending them to RESTbucks, the main module, but send them to that service. I need to start thinking about that. And the reason is that I can use like a router, or I can use like something like Spring Cloud Gateway to do that. Or I can go, since in this case RESTBux is using a HDOS, I can use hypermedia. So when it's saying, hey, where do I get my links at? You can refer it to the dashboard service when instead of RESTBux, and you can do that through configuration. So the third step, I need to take that code that's in my module and move it to my new microservice. Now, is it an easy, clean move? It's pretty easy and clean, but then again, I'm going to probably use a different technology. And if I do, there's going to be some tweaks I have to make. So the first thing I'm going to do is I say, go back and we're going to look at dashboard. I'm going to take and create dashboard. I'm going to copy that over. I'm going to copy core because it depends. I have that listed to the order, but I may want to take that whole module with it and carry it over to my new app. But in this case, I said, no, I just need order paid. So I may just put that as a part of the dashboard package. It's up to what? Your design. Once you've done that, you will now start working on your your dashboard service. Notice that dashboard service kind of looks like a monolith itself. Why can't a microservice take advantage of the things that a Spring monolith provides? A microservice can be a monolith at the same time. It doesn't mean big, it just means modularized. Okay. Fourth thing we're going to do, we're going to refactor our code once we move it over. Our main refactoring that we're going to be looking at is, as Cora said, it's inside the RESTBux app. We want to, when these order paid events are published, we need to have on our dashboard app an application module listener so we can grab and take action with that message. When we move it to our microservice, if we were using Rabbit, we're going to use the Rabbit listener. If it's Kafka, it's the Kafka listener. And then again, you're going to specify the queue or topic you're listening to. In this case, it's order paid. And since we're getting it through JSON, we want you to use the JSON message converter. Now, once we've done that, we're going to run the dashboard service in parallel with the RESTBux. And then we're going to begin basically rerouting that message to our new service. And then finally, we need to remove our module out of our application, the RESTBux application, and we've migrated. Now, I think there's some additional benefits that we want to add to our app before we really kind of do that release. What would they be?
Right. All right. Well, so here's where Spring Cloud can help you. So we've already seen, we said it can be a generic router, a generic gateway. But of course, if you're in the Spring ecosystem, and some of you have already said you're using Spring Cloud Gateway, of course, Spring Cloud Gateway is the perfect tool to use to provide that routing. Also, if you are deploying in a way where the endpoints, the precise IP address of RESTBux or dashboard service can change over time, or they might become scaled, then you can also add a discovery server so that RESTBux and dashboard service can, when they start up, they can register their exact endpoint within the discovery server. And so Gateway, before it actually forwards a request to the right place, it can obtain the exact and precise location. And config server, of course, if you want to either just be able to manage all of that configuration more centrally as you scale your system or as you distribute it further, then you can use config server to do that. And then these applications, RESTBux or dashboard service, can monitor that and then trigger and update their configuration properties when the properties through the config server changes. So those are some key ways. Also, just keep in mind, we said this earlier, right? Just because you don't have microservices doesn't mean you don't have distribution needs. You might be just scaling a monolith or a monolith alone, or these systems also connect to other systems, right? That are outside of this part of an application, and so you can also leverage Spring Cloud projects to help you with those kinds of distribution needs. So they're still really useful. And then the Spring Cloud, set of projects in general has other things. So config management, service discovery, API gateway, we've talked about. The gateway can also be used to centralize security, for helping you refactor and protect your API from changes as you refactor things in the background. It's a good monitoring point. There's a lot of different use cases where the gateway is useful. Spring Cloud also provides facilities to do circuit breakers and resilience. So if something fails, you can define a fallback so it doesn't impact the user as much. And then when that thing that's failing comes back online, then the circuit breakers will again send traffic to that system that was failing. That will happen automatically. Distributed tracing, we talked about how Monolith, in fact, just takes advantage of that, but that's part of Spring Cloud. Messaging and eventing, we've also seen that being taken advantage of by Monolith, but also useful in general when you're talking about distributed systems to think about using messaging as a way of communication. And there's also the Spring Cloud Contract project, which helps you verify that your APIs are compliant with expectations and produce stubs so that clients can also test against what actually the contract is as provided by the server. So that is all part of Spring Cloud to help you with your distribution needs. So as a takeaway, I think that the key thing here is that Spring Boot remains your technical foundation when you're creating applications with Spring. But it generally is oriented around technical needs, right? Technical stacks and boilerplate code and patterns and things like that. So Spring Monolith, in our opinion, is equally foundational as Spring Boot, but it brings in an architectural set of opinions. So they're both foundational, but they're addressing different needs. And then as your application has any kind of distribution need, then the Spring Cloud project is still relevant. So these are all complementary. It's not monolith versus cloud. It's monoliths and distribution needs through cloud. So with that.
Okay, so lock the doors. Y'all have homework. You're like, oh, Glenn, we got this. Oh, no. So a couple of things I want to bring up before we talk about your homework. Okay, one of the things that we're going to be looking at is that through Spring Monolith 2.0, we already talked about that it does have the ability now that, remember how we showed the testing, you can actually set it where it will actually fail at startup if you want to, that says, look, this app is not architecturally set up properly. So you have that choice as far as 2.0. The other thing that I think is significant, do you remember when she showed you how we have persistent messages through a relational database? You're like, what if we're running Mongo? It will support Mongo in 2.0. There's going to be also a lot of other features. You can check the milestone 1 release of Spring Monolith that talks about that. But the other thing is it will also be Spring Boot 4 compliant as well upon release. And it will be released after Spring Boot is released. So keep an eye out for that. And that's scheduled for November, December-ish. I'll go to the disclaimer. Whatever Glenn says, you ignore. But why did we give you homework? And the first thing is I said, look, I want to have a proof for you. I want y'all to see something. And I want you to see the migration progress. So what you're going to do is when you go there, you're going to see that there's a main project. And it's just the regular Spring Bucks project. It is just the monolith, the monolith. We've already taken that far for you. But then what happens is you're going to see 3 branches, of course, the main. Then you're going to see where we extracted out the dashboard itself, right? And the dashboard's running in parallel with the app. So you can see how we did that migration between the two. Then you're going to have a 3rd branch that's going to have the gateway inclusion, right? And the reason I broke it up that way is I wanted you to have those choices to say, 1, what does the original module by itself look like? All right, what if I want to run the gateway run the dashboard separately, but then maybe I tweak and say, okay, in my hypermedia, please reference the new app instead. And then the 3rd, I want to be able to do it like exactly how they showed us as a final product. So while you're here you're like, I've eaten lunch, I'm happy, I want to place it with code. Play with it. And then you can find me at the lounge. Just grab me and be sure to talk with me. The second part is this is a gist written by Oliver Dropbaum. And this is a very good discussion of why you may want to look at modules or microservices. It is a table, and it is very, very well written. So please take a look at that.
Oliver is the creator and lead of Spring Monolith.
Yes, it is very good. Now, please take a survey. Tell us how we did. And forget about the homework part. With that being said, folks, I will give you a couple other things. 1, if you have any questions, please come up and ask us. Two, if you're like, I need to know more about this, can I spend about 15 or 20 minutes with you, Glenn? Come to me and schedule some time with me, and I can meet you in the lounge and we can cover this topic in depth. To maybe say, okay, Glenn, this is what we're doing. How can we take advantage of Monolith and maybe even some of the microservice work? So please come up and
questions now.
Yeah, we got time for questions now if you have them. And that's it. We have 10 minutes.
Thank you.
Thank you.
Thank you for coming. Yeah, any questions? We'd be happy to hear what you think. Yes.
Go for it. Why not? If you have a web app, again, how's that web app? It's still going to have the domains in it, right? It's the extraction of those domains out. Now, the thing is that sometimes I'm like, how much do I want to go into detail? Because if we look, y'all are going to be like, Glenn, I'm going to get a headache if you go too fast. But I'm going to do it anyway. I'm going to go back to this slide. How many have a headache yet? Raise your hand.
How many what?
So I think it's here. We got to go past these. I apologize. Okay, and a couple more. So I want to go back to that slide that showed, man, we had a lot of slides.
It's like the fourth slide.
Here we go. All right, so you have a model view controller type of thing, right? What happens to that when I go to a monolith design? In that case, each module will have its own model view controller. The key element to remember when you do that is that if I make a change to, let's say, the order module, what will happen is that will stay in that order module. It does not spread to the others. Thus, the API remains consistent unless I have to make an API change. But what do we do then? You do that on a version, right? The versioning is critical here. It's in place, but if you have, one of the other scenarios they had is that you can actually have multiple teams working in the same module at the same time. Each team is dedicated to what? One module.
But you're asking if you only have a single module inside of an app, if you would still add Monolith? Is that the heart of your question, or no?
Yeah, absolutely.
Yeah, you don't need it.
You don't have to if you're not sending messages. Absolutely not.
Yeah, so the messages is more like you can still have one module leverage another through a direct call, as long as those two so you have two packages and there's two top level classes. Even like Monolith can only add to the Java compiler, right? So normally if you have two packages and you have two classes, then you have to you want package class A to use something in class B, you're obligated to make class B public, right? And then even in package B, if you create a sub package and then put class C in there, and you want even from B to talk to C, you're forced to make class C public. So the Java compiler basically forces you to exceed yourself in what is public, right? So instead, what Monolith does is it can't take away from the compiler, but it can say, even if class C, which is in the subpackage, is public, I'm not going to allow class A in this other module. Class B can touch it because it's the same module, right? It's like your own microservice touching its own inside code. But class A shouldn't be able to see anything in module B that module B wouldn't expose if it weren't a microservice running across a network hop. So it's helping you do that, right? So then, so it doesn't really matter what your app is. If you have two things where if you separated them, the network would somehow protect the second thing from something else accessing some internal implementation, then Monolith is going to help you make sure that you are enforcing those boundaries, even if those two things are running in the same Spring Boot process.
Absolutely. Yes, go ahead.
We expect it to be as.
I couldn't hear. I'm sorry.
No, so it can be, you can have a direct call. I don't know that you would want to make an actual network community, but you can just make a direct code reference But as long as you're doing it from a top-level class to a top-level class in another module, that is allowed. Because anything that's at the top-level class, so yeah, it's still okay. You don't need to go through events. The reason that Monolith has special support for events is because when you use the default application event infrastructure from Spring Framework, the default behavior of that, as I explained earlier with the commit boundaries and the synchronicity, it's not what's the most efficient, or it's not the most efficient configuration for Monolith. So, module A publishes a message into the application events messaging infrastructure. Module B picks up that message. So module A, that publishing method that opened that transaction, has to wait until every single subscriber, every other module that's going to read that event, they all have to finish processing it. And so while it's maintaining the commit boundary so that if you lose it, it can republish it, it's also holding this one up. So what the application module listener annotation from Monolith does is it changes that default behavior. It allows the publisher, because if you think about how this would work if you did have Kafka or JMS or Rabbit in the middle, is that the publisher would publish the message, the messaging infrastructure would acknowledge receipt, and that becomes the center of persistence. When you're inside of a monolith, the application events infrastructure doesn't do that. So the publisher has to be the one that guarantees that the message won't get lost. So it's mimicking the behavior if you did have external messaging, except to give you that persistence that would otherwise be the responsibility of Kafka or JMS or Rabbit. It uses an underlying database table. So the messages actually get published to a database table. And so then if the application crashes, the subscribers still have a persistent storage from which to reread those messages. And in the meantime, the other benefit is that the publisher has received that acknowledgement from the infrastructure, from the database table that Monolith is using, and can go on and process other events. So it's just because that default behavior requires some configuration, and Spring Monolith wants you to get that right and wants it to be easy to get it right every time. So it wrapped all of that configuration into a simple annotation. If you're doing direct code usage from the top level, from one module into a top level public class in another module, which is totally okay according to Monolith, then you don't need extra support. So it's not saying don't do that, but you can just do it on your own. That's fine. And you'll find that because you're doing that, if you were doing HTTP calls between separate microservices, you also would have to do a lot of unmarshalling and marshalling of things that happen in the background. So you're losing that network hop, and also you're avoiding all of the sort of HTTP background processing that has to happen. So it becomes more efficient, of course, as well, right? If you're doing it within a module, just direct access from one to another rather than an HTTP call. But then when you separate it, you can either continue to use messaging or do HTTP. So yeah, it's not. I think, the asynchronous message-based interactions have some advantages, but there's either one is fine. You can still follow either model. Yeah.
Okay. Do we have any other questions? All right. Yes, sir. Go for it. Please, go right ahead.
Forgiven.
A monolith, in one scenario, was exploded into 50 microservices. And that's now rather complicated to manage and maintain, especially on Kubernetes for a small form factor installation. How could this type of monolith scenario help to reconstitute?
Yeah, great question.
So one of the things that the term may be incorrect, but do you remember how we used to denormalize tables in a relational database? You say, okay, we're going to normalize it out, and we're going to have 1 million tables. Then we look at it and say, that is not practical for some of the stuff that we do, so we denormalize it. What I have seen in the production environments is where I've talked to people. Again, I'm in Atlanta Java users group, so I talk to a lot of developers. And one of the comments that we got, and I've heard this more than once, is that they took and they created all these services, but they realized that there's this one group of services that they don't talk to anything else but themselves. And there's a one lead in, and then they communicate themselves, and then it comes back out. So what they've done is they took and aggregated those services to remove the hops, right? Into, this is not with Spring Monolith, but they put it back into a monolith, right? So they put those services in monolith. But then I wanted to take a pause on that. Is a microservice always small? No. I saw somebody go, you went, oh no, right? A microservice is a service, and it can get fairly large. But what you do is you can take those services that is impractical, keep them that way, and put them into a single app. But that's when you're going to say, I'm going to reverse and make it into a module. Don't lose those domains. Don't lose that, that separation you created. Just move it back into a single app, but enforce that using Spring Monolith.
And then it's kind of the reverse of the previous question, right? Like if you're taking your microservices, each one, so we took one module, one package, and put it in a separate Spring Boot application. If you have many applications, you just take all of those and you copy paste them into one code base. Each one is a top level package, and you can enforce the rules. But also you might want to consider where you were doing things like HTTP calls, or you might want to consider your module interactions and rethink. Maybe you can have some performance improvements if you don't go through a network hop and out and through HTTP. So you could just also take a stepwise approach like we showed, just combine them and have them working, and then find opportunities for refactoring and increased efficiency. Yeah.
The key to it is the functional domains.
Yes.
Yes.
Complementing one another in smaller modules.
Absolutely. And I think the thing that we have to get over is when we think about modulists, is that modulists are not always just that monolithic app that sits and nothing else touches it. All of our apps live in distribution, right? And it's like the slide that Cora had. So with that, we have to think of how do they flex and grow and change? Our architecture is always dynamic based on what we learn. And that, from the 1.0 to the 2.0 to 3.0 release, we make those changes and we adapt.
But I think it's really great because there's, the refactoring slide that we showed where you have less infrastructure, right? You can now refactor more easily. This one, not that one. Well, maybe I can't find it. But the one where you don't have to use a strangler fig pattern, right? You have less infrastructure. So because you're refactoring a monolith in place, suddenly there's a lot of old monoliths that companies haven't wanted to touch because, it's just too much risk to break something that was working. And a strangler fig pattern is complicated to start to extract code and actually put it somewhere else and have all this infrastructure around it. So if you can now use Monolith, maybe there's old monoliths that you now can consider modernizing using this approach. And then the reverse that you're saying for those monoliths or even those greenfield applications where we kind of went overboard because microservices was the only alternative. And now we find ourselves with additional challenges, not only on the operations side, but also to developers dealing with the sprawl of Git repositories. Now you can also work that backwards. And so from both extremes, you have an opportunity now to kind of come to this center position of Monolith. And Monolith now with Spring Boot, the Spring Monolith project has the enforcement that you need to make sure that you are following these rules and doing it in a consistent way across your organization, so that we don't go back and the SOA days. This functional decomposition existed before Monolith, right, and before microservices. So those ideas were there, but what wasn't there was the ability to enforce this discipline or to even have the confidence that we had done it right. It's so easy to make a code call to another class in our application, right, and then you lose track of that, and nobody knows if it's really spaghetti code or not anymore, right? So Monolith is just kind of enabling us to take those ideas and really implement them successfully. So from both of those extremes, we can now come to this middle ground, and hopefully it'll help both development and operations become simpler.
Cool. All right, folks, I want to say thank you. I appreciate y'all being here. The questions you asked were spectacular. If you want to ask more questions, come on up front. If you wanted to schedule some time with me to say, hey, can we just talk about this a little bit more detailed in the lounge? I love the hammock. I'll just rest rocking back and forth as I answer your questions. But I want y'all to have a great day, great conference. Please come up and ask questions. Thank you.
Thank you so much.